So this video is going to cover an introduction to truth tables. We have been using ladder logic to analyze relay schematics. And in a sense, truth tables are, you could think of them as an extension of the ladder logic tables, or you could think of the ladder logic tables as an extension of truth tables. So really, we were using zeros and ones for our ladder logic tables, and that's binary. Well, truth tables are also binary in the sense that your choices are going to be true or false. So again, just two choices. And what I'd like to do is just give you an introduction and give you just a little bit of background on what they're used for. Truth tables can be used in logic. You can make a logical argument using a truth table where you compare the relative equivalence of two statements, and then you can also use them to argue a point about a specific statement. So to get started, I'm going to keep the table real simple. I've just got a P and a Q here. And so let's assume P is some statement and Q is some statement. And what are the possibilities in terms of their truthfulness? So let's start with just P and Q. So let's think about how many different possibilities there are. Well, again, because this is binary, in other words, we just can choose between true and false, we're going to use 2 as our base, and the exponent here will also be a 2, and that 2 for the exponent is because we're only looking at two statements, P and Q. And so 2 to the second, of course, is 4, and that means there's 4 possibilities. So just like when we did the zeros and the ones, we're going to start out with assuming P it can be true in 2 scenarios and false in 2 scenarios. And of course, Q could also be true or false in 2 different scenarios. And we want to make sure we consider all the possibilities. So I'm going to start with a true with Q, but then I'm going to alternate back and forth, just like we did with the ones and the zeros, okay? So now we've got this truth table set up, and we've got a column for P and a column for Q. As you can see from the table then, we've got the first possibility that both P and Q are true. And then, of course, P could be true, but Q could be false. P could be false, but Q could be true, or they could both be false. So that would be just the general setup. And then, of course, there are other things that we could consider or look at, and that would be the negation of these statements. So, for instance, the negation of P would be not P, and we would use a tilde symbol and put that in front of the letter P. And then same thing for Q, not Q would be symbolized by a tilde symbol, and that would be read as not Q. Since these are the negation of P and Q, they are going to be the exact opposite of whatever P and Q are. So if I'm filling in my not P column, I'm simply going to look at my P column and do the exact opposite. So not P for the first scenario, of course, would be false. Not P for the second scenario would also be false. And then not P for the last 2, of course, would be true. And we will use the same technique for not Q. So Q is true, then not Q is going to be false. And when Q is false, not Q is going to be true. So again, it's just going to alternate, but it's going to be the opposite of what the original column looked like. Okay, so now let's look at 2 other possibilities to consider. We still have just P and Q, so we're still, as far as how many combinations, we're still looking at 2 to the second, and that's still 4. So if I fill in my P and Q columns, P can be true and Q can be true, P can be true and Q can be false, P can be false and Q can be true, or of course they can both be false, okay? Now, what do these next 2 columns represent? Well, the next column is saying if P or, that the symbol means or in logic or in truth tables. So that reads P or Q. And so what we're saying there is if P or Q is true, then the statement is true. The P or Q column will have a true in it. So when I look at the first one, both P and Q are true, so that's definitely true. Now, because it's an or statement, I only need one of them to be true. So when I go to the next possibility of P or Q, it is also true because P is true. And likewise, for the third one down, it's going to be true because Q is true. Now, the last one will still be false because both P and Q are false. And then the last column for this table says P and Q. So an upside down V almost looks like the letter A for and. This is read P and Q, and that means in order for this to be true, they both have to be true. So when I look at my first P and Q, they are both true. So P and Q are both true. Now for the and statement, the minute one of them is false, the and statement is false. So I think you can see that for the next three, P and Q is going to be false. Okay, so that's the next set of possibilities, just to look at P and Q and then look at their or statements. I'll label this up here. This is your or statement and your and statement. Okay? Okay, so here is a challenge problem for you. I would like you to copy this chart down on your own paper. Decide how many different combinations you need to consider. You can think back to your relay logic tables, the ladder logic tables, and how many possibilities we had when we had 3 different relay contacts. And then you can also, if you want, if it helps you, you can add columns to this table that I have not included, or you can try to reason some things out in your head. But you are to complete this table, take a picture of it, and turn it in on Canvas. This is due by midnight on Tuesday, which would be November 17th. Good luck. You can email me if you have questions.